This video we will be discussing about Physics Paper 2 AS Level Structured Question 2015 October-November. Variant is 22 and the subject code is 9702. Number 1 Part A. The frequency of X-ray is 4.6 into 10 to the power 20 Hz. Calculate the wavelength in picometer. So to calculate the wavelength in picometer, first of all, what is pico? Pico means 10 to the power negative 12. 10 to the power negative 12. Similarly, giga means 10 to the power 9, mega means 10 to the power 6, kilo means 10 to the power 3, k is small letter, then deci means 10 to the power negative 1, centi means 10 to the power negative 2, milli means 10 to the power negative 3, micro, that is similar as mu, is 10 to the power negative 6, nano means 10 to the power negative 9, and pico means 10 to the power negative 12. 10 to the power negative 12. So we need to calculate the wavelength in picometer. So we know the equation V is equal to F lambda. By using this equation, we know the value of frequency, and since it is X-ray, so it is an electromagnetic wave, so its speed is 300 10 to the power 8. So after substituting the value, we get the wavelength as 0.65 picometer. Distance from Earth to a star is 8.5 10 to the power 16 meter. Calculate the time for light to travel from the star to the earth in gigasecond. So as we have discussed earlier, that giga is 10 to the power 9 and mega is 10 to the power 6. So giga is 10 to the power 9, so we need to find the time in 10 to the power 9, that is giga. For a light, we know that light is an electromagnetic wave, so its speed is 300 10 to the power 8 meter per second, and we know the distance, that is 8.5 into 10 to the power 16 meter. After substituting the value in V is equal to d by t, so t is equal to d by v, so we get our answer as 0.28 into 10 to the power 9, that is giga. So 0.28 correct to two significant figures as our final answer. And you have to remember that most of our answers in physics, we have to give our answer in two significant figures, that is 1, 2, 2 significant. This is also 2 significant. And for significant figures, you have to remember that this is two significant figures, this is 3 significant figures, that is 1, 2 and 3. But if we consider this, then we have to count from this side, that is 1, 2. So 2 significant figures. Then 800 is 1 significant figure, because after 8 we can count the zeros, but we have to count the zeros in this form, that is this is 1, 1, 2, 3, 4. This is 4 significant figures. The following list contains scalar and vector quantities. Underline all the scalar quantities. Vector quantities have both magnitude and direction, while scalar quantities have magnitude only. So mass is a scalar quantity, power is a scalar quantity, temperature is a scalar quantity, but weight has a direction, that is vertically downwards. Then force has some direction, acceleration has also some directions. So these 3 are vector, while these 3 are scalar. In part D, a boat is traveling in a flowing river. Figure 1.1 shows the velocity vectors of the boat and the river water. So this is the velocity of the boat, and this is the direction of the velocity of water. The velocity of the boat in still air is 14 meter per second, that is 14 meter per second, and the velocity of water is 8 meter per second from 60 degree north of east. So this is the velocity of water, and the velocity of water is 60 degree north of east. So this is north, south, east, west, and since the off is in front of east, so we have to count the angle from the east, that is off is in front of the east, that is from east the angle is 60 degree. So from east the angle is 60 degree. Now in part 1, on figure 1.1, draw an arrow to show the direction of the resultant velocity of the boat. So this is a 1 mark question, though to draw this arrow, first of all we need to draw for the velocity of water in this direction, we need to draw its vertical and the horizontal component of forces. That is, the vertical component is, since this velocity is 8, so the vertical component is 8 sin 60 and the horizontal component is 8 cos 60. So the resultant velocity in the vertical direction is only 8 sin 60, that is in this direction, and the resultant velocity in the x-axis is 10, that is, since the velocity of the boat is 14 meter per second minus the velocity of water, that is 8 cos 60, and 8 cos 60 is 4, so 14 minus 4 is 10. So in the horizontal direction the velocity is 10, and in vertical direction it is 8 sin 60. So after calculating by using tan, that is tan theta is equal to opposite by adjacent, we get the value of theta, that is 34.7 degree. So the value of theta is 34.7 degree, that is from east the value of theta is 34.7 degree, that means somewhere at this side. Then we need to just draw this value of r, or the line r. Then determine the magnitude of the resultant velocity. So to find the magnitude of the resultant velocity, we know the resultant velocity in the horizontal direction and in the vertical direction. So the resultant velocity is in this direction, that is r, and to find this value of r, that is this value, we need to use hypotenuse square is equal to opposite square plus adjacent square. So that is opposite is, or 10 square plus 8 sin 60 square, that is 10 square, and 8 sin 60 is 4 root 3 square. So we get the resultant velocity as 12.165. This is 5 significant figure, and correct to 2 significant figure, the answer would be 12. This is our final answer. Question number 2. Figure 2.1 shows an object M on the slope. So this is the object M on the slope. M moves up the plane. So M moves up the plane and comes to rest at point Q. So at point Q, the velocity is 0. And then moves back down the slope to point R. Then again it moves downwards to point R. M has a constant acceleration. So whenever we have to use the equations such as v is equal to ut or s is equal to ut plus half at square, we have to assume or given that the acceleration is constant, that is 3 meter per second square down the slope. That is, down the slope the acceleration is constant. Then at time t is equal to 0, m is at point P, so it starts from point P at time t is equal to 0, then has a velocity of 3.6 meter per second up the slope. The total distance from P to Q and then to R is 6 meter. That is, the distance from P to Q and then to point R is 6 meter. So calculate for the motion of M from P to Q, that is from P to Q, the time taken. So as we know that the final velocity is 0 and we know the initial velocity, that is 3 meter per second. So v is equal to u plus at. We know final velocity, initial velocity and acceleration. Since we have not given the value of acceleration, but as we know that M has a constant acceleration of 3 meter per second square down the slope at all times. At all times means that down the slope it has a 3 meter per second, and also for up the slope it is also 3 meter per second. That means in respective to this slope the acceleration is 3 meter per second square. That is, instead of giving that the air resistance is negligible or the resistance is negligible, it gives us that the acceleration is constant whether it is up or down the slope. So acceleration is 3 meter per second square, and by using this information we get the value of t as 1.2 seconds, correct to 2 significant figures. And for this question, though it is not clearly stated that acceleration down the slope, acceleration up the slope, that is from P to Q, is 3 meter per second square, but to solve it we need to get some value of acceleration, and since it is same at all times, that means whether the value of acceleration is up or down, it remains the same. But since down the slope has the acceleration of 3 meter per second square, that means obviously up the slope would have an acceleration that is negative 3 meter per second square. So it would be negative 3 meter per second square up the slope. For the movement from P to Q, we need to find the total distance table. That is, from point P to point Q, the total distance table. We know the initial speed, so s is equal to ut plus half at square. We know the value of u, that is the initial speed, that is 3.6 meter per second. Then we know the value of time, so s is equal to ut plus half at square. We know the value of time. Then the acceleration would be, since acceleration down the slope is 3 meter per second square, so acceleration up the slope is negative 3 meter per second square. So after substituting the value, we get an answer that is 2.16 meter, and corrected to significant figure it would be 2.2 meter. That is the distance. Then in part B, show that the speed of M at point R is 4.8 meter per second. That means the speed of particle M at point R is 4.8 meter per second. To find the speed at 4.8 meter per second, first of all, we need to find the distance, that is the distance QR. So what is the distance QR? We know the distance that is from P to Q and then to R. That means the distance from P to Q and then to point R is 6 meter. So what is the distance from Q to R? That is the total distance minus the distance, that is PQ. So what is the distance PQ? We know that the distance from P to point Q, that is 2.2 meter. Since the distance from P to Q is 2.2 meter, so the distance from Q to R would be 6 minus 2.2. That is, this total distance minus the distance PQ would be the distance PR. So we know the distance PR, we know the distance QR, we know the distance QR, and we know that the initial speed, that means at point Q, is 0. So we know the initial speed is 0 and the distance, that is 3.84, and whenever we need to calculate the value, instead of using the value that we have just assumed or approximated, we have to use the calculated value because it is a larger number of significant figure, that is 2.16, instead of using 2.2 because it is our approximate value and it is connected to significant figure, so we have to use a much larger value to get an appropriate answer. So instead of using the answer, we have to use the answer that is approximated, that is this value. So 6 minus 2.16 comes to be 3.84 meter. So the distance from Q to R is 3.84 meter, and by using the equation v square minus u square is equal to 2as, we know the initial speed, that means at point Q at the top of the plane, is 0. So speed at Q is 0 since the particle comes to rest at this point, so speed is 0. Then v square minus u square is equal to 2as, so we know the acceleration, that is down the slope, is 3 meter per second square, and we know the distance QR. So after substituting the value, we get the speed of m at point R is 4.8 meter per second. In part C, on figure 2.2, draw the variation with time t for the velocity of m for the motion from P to Q and then to R. So for this motion, we know that the velocity at point P, that is at the starting point, the velocity is 3.6 meter per second when time t is 0. So at time t is equal to 0, the velocity is 3.6 meter per second, that means at this point. Then at point Q, the particle comes to rest, that means velocity is 0. So at point Q, velocity is 0 and the value of time is 1.2 seconds. So at point Q, the velocity is 0 and the time is 1.2 second. That means this is point P, this is point Q, and then at point R, we have found that the speed is 4.8 meter per second. So at point R, the speed is 4.8 meter per second, and since we don't know the value of time at point R, so just we have to extend this line to point that comes to be 4.8 and get the time value. That means at this point it has a speed of 4.8 negative 4.8 meter per second. That is, since we don't know the value of time, thus we need to just extend this line until we reaches a speed that is 4.8 meter per second, and this would be the final point. Though we know the value of don't know the value of time, but we need to just extend this line to get the speed as negative 4.8 meter per second to draw our line. And for a velocity time graph, you must remember that the gradient of the velocity time graph gives us acceleration. So as we know that initially the acceleration is constant, since acceleration is constant, so the gradient would be a constant line with a decreasing gradient. Then in part D, the mass of m is 450 gram. So we know the mass of m. Calculate the difference in kinetic energy of m at point P and at point R. So we know that the speed, since kinetic energy is equal to half mv square, where v is the speed, not the velocity. So we know the speed at point P, that is 3.6 meter per second, and at R, the speed is 4.8 meter per second, that is 4.8 meter per second. So we need to find the difference in kinetic energy. So difference in kinetic energy would be half mass. We must divide this by 1000 to get the mass in kilogram. Then half mass into speed square, that is final speed minus final speed square minus initial speed square. This would be the case, but you have to remember that most of you just do this as 4.8 minus 3.6 whole square, but instead of doing this whole square, you have to square 4.8 separately and square 3.6 separately, and then subtract this value to get the kinetic energy as 2.268 correct to 4 significant figure. And to get our answer to significant figures, we have to approximate it as 2.3. Since this number is greater than 5, so we have to just add here 1, that is 3. Initially it is 2, but now it becomes 3, so correct to significant figure, the kinetic energy is 2.3 joules. 3. A trolley T moves with a speed of 1.2 meter per second along a horizontal frictionless surface. That, as it mentions about that the surface is frictionless, that means there is no effect of friction. Then the trolley collides with a stationary block to one end of a fixed spring as shown in figure 3.1. So this is the block and the trolley collides with the block. The mass of T, that is the trolley, is 250 gram, and T compresses the spring by 5.4 centimeter, and then the trolley, that is T, comes to rest. That means V is equal to 0. The relationship between the force applied to the block and the compression X of the spring is shown in figure 3.1. So this is already given, and this is a straight line. That means force is directly proportional to extension. That means the spring obeys Hooke's law. Then use figure 3.2, that is this figure, this is actually 3.2, okay. So use this figure to find the spring constant. We know that the spring constant is equal to force by extension, or force is equal to spring constant into extension. So after getting any of these values, that is substituting any of these values, we get the value of K, that is 2.6 by 3.2 divided by 100. Since it is in centimeter, so we need to convert the extension in meter by dividing with 100. So the spring constant comes to be 81.25, and correct to significant figure, it would be 81 Newton per meter. In part B, the work done by T compressing the spring by 5.4 centimeter. So we know that the total work done is equal to total energy conversion, and we know that the energy that is converted, that is the kinetic energy of T that is converted, is the elastic potential energy, and we know that the elastic potential energy, the expression for the elastic potential energy is half Fx or half kx square. So by using the expression that I have used, that half kx, half fx, so half, and we know the value of extension. So for this extension, what is the value of force? So from the graph, remember that this is not the extension axis, this is the extension axis. So when the extension is 5.4, that is at this point, we need to find the value of force, that is approximately 4.4. So the value of force is 4.4. So after substituting the value, we get our answer as 0.1188. This is for significant figure, and correct to significant figure, the answer would be 0.12. The spring expands and causes T to move in the direction opposite to its initial direction. That means initially we can see that T is moving in this direction, but due to the expansion of the string, T now moves in the backward direction. So for this movement of T that is in backward direction, at the time that T loses in contact with the block, it is moving with a speed of 0.75 meter per second. That means it is moving in this direction with this speed. For the time that T is in contact with the block, describe the energy changes. Since we know that there is a constant increase in elastic potential energy, also we can see that since the surface is frictionless, that means there is no frictional force. That means the total kinetic energy is converted to the total elastic potential energy and total kinetic energy of the block. That means the total kinetic energy of T is converted to total kinetic energy of the block and the total elastic potential energy of the spring. Then again, as the spring expands, the total elastic potential energy is again converted to total kinetic energy of the block plus total kinetic energy of the T. So initially the kinetic energy of the trolley, that is the T, is converted to the kinetic energy of the block and the elastic potential energy of the spring, and as the spring expands, that is it expands, the elastic potential energy is again converted to kinetic energy of a trolley and the kinetic energy of the block. So this is the answer. Then determine the change in momentum of T. So we know that the momentum is equal to, change in momentum is equal to mass into change in velocity. So we know the value of mass, but we need to divide this by 1000. Then the change in velocity, that is the initial velocity, that is 1.2 meter per second, and the final velocity is 0.75, but since the final velocity is in opposite direction, so initial velocity minus, so change in velocity would be just the change in velocity would be final velocity, that is 0.75 minus initial velocity, and since initial velocity is in opposite direction, so overall it would be just a plus. And if we consider change in velocity is equal to initial minus final, that is initial velocity is in this direction, so initial velocity, that is 12, minus final velocity is in this direction, so minus 7.5, 0.75, sorry, this is 0.7, this would be minus 0.75. So 1.2 minus 0.75, the overall answer comes to be a plus, that is the plus of these two velocities. Since minus minus causes a plus, so this would be 0.4875, and correct to significant figure, it would be 0.49 as a change in momentum in Newton second. Number 4, part A, define the moment of force. So the moment of force is the product of force and the perpendicular distance from the pivot to the line of action of force. That is, the product of moment of force is the product of force and the perpendicular distance from the pivot, or the perpendicular force and distance. Then in part B, the arrangement for lifting the heavy load is shown in figure 4.1. So this is the diagram. So for this diagram we have given these statements. Okay, so uniform metal beam AB is pivoted on the vertical wall at point A. So this is the point A. Then the beam is supported by the wire joining the end B to the wall at C. So this is end B and it is joined to the wall at C. Then the beam makes an angle 30 degree with the wall. So this is the angle 30 degree with the wall, and the wire makes an angle of 60 degree with the wall. So the wire makes an angle of 60 degree to the wall. The beam has a length of 2.8 meter. So what is our beam? Our beam is this beam AB. So the length of this beam is 2.8 meter and the weight is 500 Newton. So since the weight of the beam is 500 Newton, that means for a uniform beam, the weight would obviously act at the point, that is the center of gravity. And since the center of gravity for this beam is at its center, so that means at the center, the weight is acting, and this distance would be the half of this distance, that is 1.4 meter. Now the load of 4000 Newton is supported from B. So this load that is 4000 Newton is supported from point B. The tension in the wire is T and the beam is in equilibrium. Since the beam is in equilibrium, that means the total clockwise moment, that is the moment in the clock direction, is equal to the total anticlockwise moment. So by taking the moment about point A, that means we need to consider the point A as our pivot. We need to find the value of tension as 2.1 kilonewton. So to find the value of this tension, that is we need to find this value of tension. So we consider this as our plane, and by considering this our plane, we know that the total clockwise moment is equal to the anticlockwise moment. So the clockwise moment would be 4000 cos 60. Since this is the 4000 Newton weight and its vertical component would be 4000 cos 60, since this angle, we know that this angle is 30 degree. So we know that this angle is 30 degree, and since the plane is in such a way that this angle is equal to this angle, so since this angle is 30 degree and this is the parallel sides and this is the bisector, so this angle is 30 degree, so this angle would be 30 degree. Thus this angle would be, since this is perpendicular, so 90 minus 30, that is 60 degree. So this angle is 60 degree, that is 4000 cos 60. Then 4000 cos 60 into 2.8 plus 500 cos 60 into, as this is half the distance, so 2.8 by 2, that is 1.4, is equal to the anticlockwise moment, that is T into 2.8. So this value of T and 2.8 is this distance, and after equating this we get the tension as 2125, that is in Newton, and we need to convert it to kilonewton. So dividing by 1000, and we have to give our answer as two significant figures. So the answer would just be 2.1. So this would be 2.1, since this is less than 5, so it would be just 2.1 as our final answer, and we have to write shown. To calculate the vertical component TV of the tension. So to calculate the vertical component of tension, we need to first draw a triangle. Since here is no triangle is drawn, and you have to remember that to calculate the vertical component, the tension would obviously have to be a hypotenuse, and this would be the vertical component. So for this triangle, we can see that this is not the hypotenuse, so we have to draw the triangle in such a way that this side is the hypotenuse, this side is the hypotenuse. So to draw this in such a way, we can draw it like this. This is the horizontal line and this is the vertical line. So the vertical component of this tension would be T cos 60. That is, TV is equal to the value of T cos 60, and the answer comes to be 1062.5, and corrected to significant figure it would be 1100, since it is two significant figure and the rest of the zero is not significant. But if it is written in such a way that this is the number, then this would be 1 2 3 4, four significant figures. State and explain why TV does not equal to the sum of the load and the weight of the beam, although the beam is in equilibrium. So for this system, we can see that the TV is acting upwards while the weight of the beam and the load is acting vertically downwards. So as we can see that at the point of contact at A, since it is a point of contact, that means at this point there must be some force that is acting, that is this force. So this force at the point of contact at point A and TV would be equal to the weight of the load and the beam. Thus the value of TV does not on its own is equal to the sum of the downward force and the weight of the load, because there is an upward force at A. So there is an upward vertical component of force at A. That means there is an upward vertical component of force at A, and the upward vertical component of force at A plus TV is equal to the sum of the downward forces. 5. A 240 volt power supply has negligible internal resistance and is connected to 4 resistors as shown in figure 5.1. That is, these are the 4 resistors. 2 resistor of resistance 550 and 950 ohm, that is 550 and 950 ohm, are connected in series across S, and 2 resistors 350 and R are connected in series across X. The current supplied by S is 0.40. That means the total value of current is 0.40. Current I1 and I2 are in the circuit as shown in figure 5.1. That means this current is further divided into I1 and I2, that is these two currents. So calculate the I1. So as we know that the current is equal to potential difference divided by resistance, and to calculate the value of I1, we know that the total resistance, that is 550 and 950, and we know that the potential difference is 240. Since across parallel circuit the potential difference remains the same, that is this is 240, so at this point this is 240 and at this point this is 240. Since they are in parallel, so total voltage, that is 240, by total resistance, that is this resistance plus this resistance, the current comes to be 0.16, corrected to significant figures. Then the resistance R. So to calculate this resistance R, we know current at this circuit, that is I1, and we know the total current. So what would be the current I2? Current I2 would be this total current minus I1, that is the total current minus I1 is the current at this circuit. So for this part or this loop, we know the value of current, and we know that the total potential difference is 240 volt. So resistance is equal to voltage by current. So total resistance, that is 350 plus R, is equal to the voltage, that is 240 by current. So the resistance comes to be 650 ohm. The ratio power transformed in the resistor of resistance 350 ohm and the power transformed in the resistor of resistance 550 ohm. So for the 350 ohm, that is this resistor and this resistor, we need to find this difference, and we know the power is equal to I square R. So actually power is equal to VI, and it can also be written as V is equal to IR. So power is equal to I square R, or I is equal to V by R. So power is equal to V square by R. So you can use any of this equation, but since we know the value of current and the resistance, so I have used this equation. So for 350 ohm resistor, we know the resistance is 350, and for 350 ohm resistor the current I2, that is the current value of I2 is 0.24, and we have to remember that this circuit is a series, that is current at this resistor is same as the current at this resistor. So the current at 350 ohm resistor would be 0.24 square into its resistance. Then the power at 550 ohm resistor would be resistance, that is 550, and the current is the total current minus the current at I2, that is the current I1, that is this current I1 is 0.16, so 0.16 square. So after substituting the value, we get our answer as 1.43, and correct to significant figure it would be 1.4 as the ratio. In part B, 2 points are labeled A and B as shown in figure 5.1. Calculate the potential difference AB between A and B. So what is the potential difference between point A and point B? The total potential total potential is, or the total EMF is 240 volt. Some of the potential drop at this resistor and the remaining should drop on this resistor. That means at point A we have the potential of 950 ohm resistor, and at point B some of the potential has dropped at this resistor and the remaining should drop at this resistor. That means at point B we have the potential of R, that is this resistor. So the potential difference would be between A and B would be the highest potential minus the lowest potential between this resistor and this resistor. So the value of potential at 950 ohm resistor is, we know the potential difference is equal V is equal to IR. So we know the value of current at 950 ohm resistor and its resistance, that is 950 ohm. So the potential comes to be 152 volt. Then at point R we know that the resistance of R is 650 ohm, that is this 650 ohm, and we know that across R the current is 0.24. So its potential value is 156. So the potential difference between point A and B would be equal to the potential of the highest resistor minus potential of the smallest resistor is the difference between the potential difference of A and B. That is this potential value minus this potential value, and the potential difference comes to be 4 volt. The resistance of R is increased. So resistance of R is increased. Study and explain the effect on VAB. So this is VAB, that is the difference in the potential difference between this resistor and this resistor, and the resistance of R is increased. So as the resistance is directly proportional to voltage, so if resistance of R is increased, that means the potential difference across R also increases. So this value would also increase. Suppose the value increases to 250, then what is the potential difference between point A and B? That is this potential difference. That means we can see that this is the higher value and this is the lower value. So higher value, that is 250 minus 152, would give a value that is 98. So this value is much bigger than 4. That means as the resistance of R is increased, the potential difference across R is also increases, that is this VR also increases, and since this higher value increases, so higher value minus lower value would give a larger difference, that is the difference would be greater than 4. So the difference, that is VAB, that is del V, is increases since the potential difference across R increases. This is a 1 mark question. Number 6. A 12 volt battery with an internal resistance of 0.50 ohm is connected to two identical filament lamps L1 and L2 as shown in figure 6.1. So for the filament lamp, you must remember that increasing the current increases the heating effect, and so increasing the heating effect would increase the resistance, and so due to increase in resistance, current again decreases. Again, increasing the current increases the heating effect, and therefore resistance increases, and as resistance increases and resistance is inversely proportional to current, so due to increase in resistance the value of current then decreases, and the IV graph for the filament lamp would look something like this. So as we can see, this is the current and this is the voltage, and this is the IV graph for filament lamp. As current increases, voltage increases, but due to increase in current, heating effect increases, and due to increase in heating effect, resistance increases, and as resistance increases, we can see that the value of current decreases instead of increasing in a proportional way. Also, this would be symmetrical to the negative axis. This would be a straight line, then it would decrease due to increasing resistance. So the lamps are connected to the battery via switch S1 and S2. So these are the two switches. The power rating of each lamp is 48 watt. So the power rating is 48 watt and the potential difference is 12 volt. So the maximum power is 48 watt and the voltage is 12 volt. S1 is closed and S2 is open. So this S1 is now closed. So state and explain whether the power transformed in L1 is 48 watts. So we need to verify that whether the power is 48 watt in this lamp. So as we can see that due to the internal resistance, the 12 volt would not exactly pass through L1 due to the internal resistance, and due to the internal resistance, thus some of the voltage drop occurs across this resistor, and so the voltage across this resistor is not exactly 12 volt. So as the voltage is not 12 volt, so power is not exactly 48 watts. So some potential drop occurs across the internal resistance, that is this internal resistance. Across this internal resistance some potential drop occurs, and so the potential difference is less than 12 volt. So it is mentioned that the potential difference is 12 volt, but due to this internal resistance there is some potential drop occurs, and so here potential difference decreases, and so power is less than 48 watts. In part B, switch S2 is now closed. Initially S1 was closed, now S2 was closed. State and explain the effect of current on L1. So as the switches are closed, so we can see that this is the parallel arrangement, and in parallel arrangement the resistance, that is the resistance across this resistor and this resistor, would decrease, since in parallel circuit the resistance decreases, and so as the resistance decreases and resistance is inversely proportional to current, so due to decrease in resistance current increases, and as current increases, so current across this resistor increases, therefore lost volt increases, as lost volt is equal to IR V lost across the internal resistance. So as current increases, so due to increase in current the lost volt increases, and as this lost volt increases, therefore voltage across this resistor decreases, and as voltage across this resistor decreases and V is directly proportional to current, so current also decreases due to decrease in voltage. So switch S2 is now closed. State and explain the effect of current on L1. So the total resistance decreases. That means as the switch S2 is closed and due to this parallel circuit, the total resistance decreases. So resistance decreases, and as resistance is inversely proportional to current, so current increases. Resistance decreases, current increases. Then as current increases, therefore as we know that V out, or this lost volt, is equal to IR. So due to increase in current the lost volt increases. Due to increase in this current the lost volt increases, and as lost volt increases the voltage across this resistors decreases, and as voltage across this resistors decreases, and as we know that voltage is directly proportional to current, so as voltage decreases therefore current decreases, therefore current across this resistors would decrease. You should follow this step and memorize this step to understand it better. So the total resistance across this internal resistance, or the total resistance across these resistors decreases, so the total current increases, that is this total current increases, and due to this total increase in current the lost volt increases, and due to this increase in lost volt, as the lost volt increases, so the potential difference or the voltage across L1 decreases, and as the potential difference across L1 decreases, so potential difference is directly proportional to current, therefore current also decreases. Steps, that is in step 1 the lamps are added in parallel, so the total resistance decreases, that is the total resistance decreases, and current through the battery increases, so as resistance is inversely proportional to current, so due to decrease in resistance current increases. Then as current increases and V loss, that is lost volt, is equal to IR, so as current increases therefore lost volt increases, that means voltage across this resistor increases, therefore voltage across this resistors decreases, and as voltage across this resistors decreases, we know that voltage is directly proportional to current, so as voltage decreases therefore current decreases, and therefore the terminal current decreases, or V terminal decreases, therefore the current across these resistors decreases. State and explain the effect of resistance on L1. So what happens to the resistance? So this is L1, and as potential difference across the L1 decreases, and as potential difference is directly proportional to resistance, or resistance is directly proportional to potential difference, so as potential difference decreases therefore resistance also decreases. You can see that the potential difference decreases across L1, therefore potential difference decreases, therefore resistance also decreases. Number 7. The arrangement that is used to demonstrate the interference with waves on the surface of water is shown in figure 7.1. So this is used to demonstrate the interference pattern. Two dippers D1 and D2, that is this dipper D1 and D2, are connected to the motor and a DC power supply. And initially only D1 vibrates on the water surface to produce waves. That is, only D1 vibrates to produce these waves and D2 is stopped. The variation with distance x from D1 is displacement and of displacement y of the water at the instant at time t is shown on figure 7.2. So for the dipper D1, the displacement, that is displacement y against distance, is given in the figure. Then use figure 7.2 to determine the amplitude of the wave. Now from this diagram we can see that y is displacement. So amplitude is the maximum displacement from its position. So the maximum displacement from this graph is 3.2. Therefore the amplitude should be 3.2 and it is in millimeter. So the answer also is in millimeter. So 3.2 millimeter. X is the distance. So wavelength of the wave. So wavelength of the wave is the distance between the 2 points that are in phase. Phase means that this point have same speed, same displacement from the rest position, and same direction of motion. That is, this point is moving in this direction, also this point is moving in this direction. So these two are in phase. Also for these points, these 3 points, we can see that this point is moving upward and this point is moving downward while this point is moving upward. Since these 2 points are moving upward, so this is the distance between the two waves is the wavelength, that is lambda, and this is half the lambda. So what is the wavelength? Wavelength is the distance between the 2 points that are moving in the same direction. That is, this point is moving in this direction, also this point is moving in this direction. So the wavelength is the distance between these 2 points, that is 20. So 20 millimeter. Part B. The two dippers D1 and D2 are made to vibrate and the waves are produced by both the dippers on the water surface. Study and explain whether the waves are stationary or progressive. So as we can see, as the dippers vibrate, some energy is transformed, and as energy is transformed, therefore these waves are progressive wave. So the wave is progressive because energy is transferred. Explain why dipper D1 and D2 are connected to the same motor. So one of the reason would be that to produce coherent waves with a constant phase difference, because this would be the only point that why these two dippers are connected to the same motor, because to produce a coherent wave with a constant phase difference. Then point A and B on figure 7.1, that is in this figure, are at a distance D1 and D2 as shown in figure 7.3. So these distances values are given. State and explain the variation with time, the displacement of water on the surface at A. So what is the displacement at point A? At point A, we can see that the waves from D1 and D2 both travel. So as the waves from D1 and D2 both travel, so we need to find what is the displacement at this point. And to find the displacement at this point, first of all, we need to find whether at this point or at that point constructive or destructive interference are formed, because when constructive interference is formed, then the path difference is lambda, and when destructive interference is formed, then the path difference is lambda by 2, and when the path difference is lambda, then the wavelength must be multiplied by 2, and when the path difference is lambda by 2, then since the path difference is lambda by 2, that means the two waves are out of phase, that means the amplitude cancel each other out. As we can see that at point A, from dipper D1 and D2, that both the waves travel. So what is the path difference? So path difference is the difference between these two paths divided by wavelength, that is the wavelength is 2 millimeter, that is this 2 millimeter, difference is both the paths minus divided by wavelength, and the answer is multiplied with lambda. So the answer we get is lambda. So as we can see that the path difference is lambda, that means constructive interference is formed, and as constructive interference is formed, that means the amplitude at that point is twice the amplitude of the wave. That is, this is the amplitude of that at this point. So the displacement would be approximately, or the displacement value is 6.4 millimeter. Then at point B, we can see that what is the path difference. So path difference is the path of highest path minus smallest path divided by lambda, that is the wavelength, and we have to give our answer in terms of lambda. So the path difference we get is lambda by 2. Since the path difference is lambda by 2, so the amplitude cancel each other out. Since they are of the same amplitude, so the amplitude cancel each other out, and the waves must have a zero amplitude, that is a straight line. Number 8, part A. The result of alpha particle scattering experiment gave the evidence for the structure of an atom. State two results and the associated conclusions. So first result would be that most of the alpha particles pass straight through without any deflection or deviation. So most of the alpha particles pass straight through without any deflection or deviation because the size of the nucleus is very small compared to the atom. Then the second result would be that a small proportion of alpha particles have deflected through a larger angle, that is an angle greater than 90 degree. This is because majority of the mass is concentrated in a small region, the nucleus, and due to this nucleus, they experience a deflection that is greater than 90 degree or through a larger angle. B. In the model of a copper atom of isotope 6329 copper, the atom and its nucleus is assumed to be spherical. Since it is spherical, so it has a volume of 4 by 3 pi r cube. The diameter of the nucleus is given and the diameter of the atom is given. But you should also remember that the diameter of the nucleus is 10 to the power minus 15 and the diameter of the atom is 10 to the power minus 10. Then calculate the ratio of density of the nucleus by density of atom. We know that density is the mass per unit volume, and for this nucleus or atom, we know that the mass is basically the mass of proton plus the mass of neutron, that is the total mass is concentrated in the center. So whatever the mass is same for the nucleus or for the atom. Since the mass is only concentrated at the center, so whatever the mass is same for the nucleus and the atom. So the mass number, from the mass number, that is the total number of protons and electrons, is 63. So the mass would be 63U, that is 63 into 1.6 into 10 to the power minus 27. But you don't need this right now because the mass of nucleus is same as the mass of atom. So we can use this ratio to solve this. That is the mass of nucleus is equal to mass of atom. That is density into volume of nucleus is equal to density in volume of atom. So density by nucleus by density of atom should be the diameter, after cancelling the diameter of the atom by diameter of the nucleus cube. After solving this, we get our answer as 5.5 into 10 to the power 11, correct to two significant figures.